Hello and welcome. My name is Frank Fischer, and in this video I want to start a little series of what I already do on the blog side. I pick juicy little samples out of what our tool finds in various code bases and simply dig a bit deeper, show how this all comes about, what's the problem behind it, what are probable remedies against this problem. And I thought maybe I do this in a video. The reason for that is that you can literally look over my shoulder. You see how I use the tools and how I go about this. So let's get into it without any further ado. What we have here is actually we have Linux. So I cloned the Linux repo here from Linus Torvalds GitHub repo /Torvalds/Linux. I literally did this and have this now on my local hard drive here. I opened it in Visual Studio Code. Since I have the DeepCode plugin installed, it automatically asked me if I want to do a scan over it. So I said yes. It kind of bundled it, sent it up to the cloud, did the analysis and brought the analysis results back. And this is now what I have here. And you can see all the yellow files here on the left side are actually files with suggestions from DeepCode. And I picked one of them, which is omap-sham.c. It's part of the crypto parts of the Linux kernel. And in here we have the one that I have highlighted here. This is the one that I would like to look a bit deeper. So you see here in line 765. Nice, 765, we have this bug here. So if I hover over it, you see that Visual Studio brings me the suggestion text, which is this division may result in a division by zero error, cause 0 is a possible divisor. Okay, so let's have a deeper look at this. You see there's a variable newlen. Newlen is up here, it's defined, it's an integer. You see integer newlen. And the formula is newlen -1 divided by bs, and bs is an integer, okay, divided by bs times bs. Okay, so first of all, first impression, interesting, because division and multiplication kind of negates itself out. So there's a kind of a zero effect you would expect in a way. But since this is an integer, what we actually have here is we're doing a rounding. Yeah, we are losing, so to say, the precision behind it, and by dividing and multiplying, we are making a rounding action. One interesting aspect on this is that obviously there is a precedence, a kind of a sequence in how these actions are actually executed. So the division versus the multiplication, which one comes first? And this is something that you can look up here in the operator precedence. And you see it's the precedence 3. We have multiplication and division, and it's a left to right thing. So what happens here is it starts on the left side. This one is executed first, and then this one is executed. And personally, I would have liked to have a parenthesis around it. I know it's not necessary, and it works just nice. But it's a bit hard to follow the intent of the developer here and make sure that the person who did this was not like mistakenly doing it this way. Okay, anyway, so we have this precedence. It will first be divided and then multiplied. So now the error says this might be a division by 0, so bs might be a 0 value. Okay, so let's have a look first. Where does bs come from? And if we scroll up a bit, you see here in the header of the function, here we have bs being defined. So obviously bs comes from the outside world. Maybe a good first step would have been to say, hey, if bs doesn't exist, if bs is 0 or something like this, I don't know, we return 0 as an error value or something, would have been maybe a nice add-on in this if statement here. But probably whoever wrote this function here was super sure that bs will never be 0 whatsoever. Okay. So maybe we want to be a bit more sure, a bit more safe in this regard, and we want to see where does this BS come from. So what we can do now in Visual Studio is we can do a right click and say go to references. And Visual Studio now will find out where is this function referenced. And you see there are two, so to say, points where the function is referenced. One is the definition where we currently are. And the other one, nicely, it's only two. The other one is where the function is used. And it's only used once. This is here, line 891, where we capture the return value in this variable red. And we are calling this function here, and we are handing over this parameter bs again. So this bs here becomes the bs inside of our function. So this bs should never be 0. Okay, now next question, where does this bs come from? I won't go now and say, hey, give me all the references, because it will probably explode. And you see bs is used quite some time here, up here. Now the question is, where does bs come from? And you see here, this seems to be where bs comes from. So if I go up here, bs is always used in a reading manner, and here it's used in a writing manner. So the get block size is the function that sets the bs value. Okay, so let's go to the definition of get block size. And you see it starts off with defining a local variable d. And then we are having a switch case statement here, where we look into the flag mode, SHA-1, SHA-224, SHA-256, and depending on that, we are setting the D value. So here, if we're going over this, Visual Studio will resolve it, and we see this will be 64. Here it becomes, come on, hurry up a bit, 64 again. Here it will be 128. So this is all not 0, but as you can see here in the default, it is 0. So if the switch statement does not fire in here, and we are literally defaulting to 0, then we're returning a 0. And then actually through the other two functions that we have, we are setting bs to be 0, and then we have a division by 0. So it is a real opportunity that d can be 0, and with this is a case that should be handled in the code. And obviously how you handle it is you check for the 0, and you have an error handling here. So this is a real one. So I hope you got some idea on how to use the tools and what kind of failure we have here. Thanks for watching, but now it's your turn. Go to deepcode.ai and check out what DeepCode can do for your code.